First video here for topic 7 for distance learning. The learning targets for today's video are I can combine like terms to simplify polynomial expressions, and I can name a polynomial based on its degree and number of terms. So hopefully at this point you have taken the notes that are attached to the slide because they're going to help you with these online lessons. The online lessons are going to be pretty short with the idea that you have taken quite a few notes before you've actually watched the video. So one thing you should have in your notes is how we name polynomials. There's two parts to how we name a polynomial expression. We have the part that tells us how many terms are in the polynomial and the degree. So in your notes, you should have written that a monomial is 1 term, a binomial is 2 terms, a trinomial is 3 terms, and a polynomial is 4 or more terms. Now when we're looking at the degree of a polynomial expression, we are looking at the highest degree for the entire expression. So 7 has a degree of 0. Because when we're looking at the degree of a polynomial expression, we are only looking at the degree of the variable terms. This doesn't have a variable term, which is why it's a 0-degree polynomial, and we call it a constant. This monomial, 4x, its highest degree of the exponent is 1. We don't write a 1 there, but it is x to the power of 1. So the degree of that monomial is 1, and that would be considered a linear polynomial expression. Here, I want to look at what is the highest degree of either term in this expression. Obviously, it's here with 3x squared, and the degree is 2. And whenever we're looking at an expression that has a degree of 2, it is a quadratic expression. Now look down here at this monomial, negative 5x squared y. This is a degree of 3 because in this term we have a degree of 2 for x. And remember, don't forget about that degree of 1 for y. And when you add those both together, that makes this monomial a cubic monomial expression. And then down here we have a chunkier expression, 4x squared y squared plus 5x. Obviously this has the highest degree, and if we add together the exponent of x and y, it's a 4th degree polynomial. And you'll notice that anything higher than a cubic monomial or expression, we just call it by its name of its degree. So 4th degree, 5th degree, and so on. Okay, so we're going to look at how we find the degree of a monomial here. Based on what I just went over right here, with these 3 monomial expressions, we can easily find the degree. This is a good point for you to pause the video, write down the problems, quiz yourself, see if you actually can figure out what the degree of each one is, and then resume the video and see if you got them right. So for this first one, the degree of this monomial is 1. We don't write it, but there is a 1 there. And so this is a 1st degree monomial. And if I were to name this, I would say it's a linear monomial. Now looking down to this next one, I have x squared, y cubed. So if I add those together, this would be a 5th degree monomial expression. Now I wrote this here, and I know if you look at the chart, you know that this is a 0 degree, but I want to explain why. I don't want you to just know that that's a 0 degree expression. And if you look at your notes, it said that to find the degree of a polynomial expression, it is the highest exponent of the variable terms. Well, for 6 and also for 7, there is no variable term. It's just a number all by itself. But one might argue, well, that's 6 to the 1st power, which is true, but remember, there's no variable here. Now, if I did include a variable here that would make this mathematically correct, it would be 6 x to the 0 power. Remember, anything that's raised to the 0 power is simply 1. So that would be 6 times 1, which is 6. And that's why any constant number or constant term has a degree of 0. So how do I name a polynomial expression? There are two parts, and it has to do with what you see on this whiteboard right here. We're naming it based on the number of terms, and we're naming it based on the degree of the polynomial expression. Hi, Belle. Come say hi. My dog Belle just walked in. Okay, so for this first one, we always start with the degree. So if I look at my variable, it's x raised to the first power. So that makes it a linear, that's part 1. And then I have to look at how many terms do I have? Well, I have one term and another term, so I have 2 terms. So it's a linear binomial. Linear binomial. Okay? So let's look at this second problem here. My highest exponent value would be 3 because this is x to the third. This would be x to the first, y to the first, which makes this monomial right in the middle here a degree of 2. So it is a degree of 3. If I look down here, that makes it cubic. So it is a cubic trinomial because there are 3 terms in this expression. Cubic trinomial. In some of your homework exercises, you are going to be asked to name the polynomial based on its degree and number of terms, and this is how you would do that. Okay, so when we're simplifying polynomial expressions, we need to write our final answer in standard form. And the way that you write an expression in standard form is you start with the term that has the highest variable power, and then you write it in descending order until you get to the constant term. So let me show you how to do that. This first one is 2x minus 4 plus 2y squared. So what's the highest variable term? It's 2y squared, so I'm going to write that first. And then I'm going to go in descending order. So my next one would be the x term, and it's positive, so I'm going to write plus 2x. And then I'm going to end with my constant, minus 4. So again, that is how we would write in standard form for this one. And if we were to name this one, it would be a quadratic trinomial. Okay. This would be a good spot to pause the video, see if you can do this one on your own, quiz yourself. The first thing you want to ask yourself is, what's the highest variable term? It would be minus or negative 3x to the 4th power. And then I'm going to go in descending order. So 2x squared. My y term plus 2y minus 3, and I'm done. And if I were to name this, it would be a 4th degree polynomial. All right, so simplifying and naming polynomial expressions. Simplifying an expression is something you've been doing since 6th grade. And as we get into larger, more complicated expressions, you always want to be asking yourself, how do I know that it's in its most simple form? And I know that when all like terms have been combined. So the question is, what makes a term a like term? Terms are like terms if they have the same variable raised to the same power. So something I used to do with my 6th graders and 7th graders is I would color code my like terms. And I know that your past teachers have done this before. So the way I would do this is I would start with my first term, which is 4x, and I'm going to pick a color. Let's do purple. I'm going to box that in. I'm going to look for my other x terms in this and box those in as well. I have plus 2x and plus x. Those are all the x terms. Now I'm going to move on to my next type of term, which would be 3x squared. I'm going to use blue for that. There are no other x squared terms in this. And 5 is all by itself as a constant, but I'm going to go ahead and box that in green. Okay? Now I'm going to go ahead and combine these. And remember, we need to write them in standard form, which means I need to start with my highest variable power. So when I'm doing this is how I start them. I look for my highest variable power, which is right here, 3x squared. There's no other terms in this expression like that, so I'm simply just going to write 3x squared. And sometimes when I have a really chunky expression, I might put a little check mark to tell me that I've taken care of that one. I'm going to move on to my next type of term, which is the x term. So I've got 4x, 2x, and remember we don't write it, but there's a 1 there and 1x. So in total I have 7x, and they're positive. Okay? Takes care of that one, and that one. And last but not least, I have my constant term plus 5. So I want to ask myself a few questions. Have I combined all like terms? Yes, I have. Have I written it in standard form? Yes, I have. And finally, if I were to be asked how to name this, it would be a quadratic trinomial. Okay? I would encourage you to do the next two on your own. Use color or not, it's up to you. And then see if you get them right. So for number 2, I'm going to go ahead and box in my like terms. I've got 4x squared minus x squared. And I've got negative 3x plus 3x. And then I'm going to combine these. I have 4x minus 1x squared, which is 3x squared. Negative 3x squared, or negative 3x plus 3x ends up as 0x. I don't need to write that. So this is the simplified version of this. Have I combined all like terms? Yes, I have. Is it in standard form? Yes. And if I were asked to name this, it would be a quadratic monomial. I'm going to do the last one without color coding. Got 7y to the third. Do I have any other to the third type of terms here? Yes, I do. I have 7 and a positive 5, which gives me 12y to the third. Check those off. And I've got negative 3y, negative 2y, which gives me negative 5y. Check those off. Plus 7. Have I combined all like terms? Yes, I have. Is it in standard form? Yes, it is. And if I were to name this, it would be a cubic trinomial. All right, that's it for today's lesson. Tomorrow we will get into more complex expressions that include parentheses.